Welcome to this video on the applications of lyophilization. Lyophilization, or freeze drying, is a process of drying a substance by freezing it and then removing the frozen water directly as vapor under low pressure. This preserves the original structure and quality of the substance, protecting delicate biological materials like microorganisms, enzymes, and cells. Lyophilization has ancient origins in primitive freeze drying for food preservation. Modern procedures began to emerge in the 20th century. Richard Altman, a German histologist, made a key advance in 1906 by successfully freeze-drying and later reviving bacteria for preservation. During World War II, lyophilization preserved blood plasma for the military, leading to refined techniques for transporting life-saving materials without refrigeration. By the 1950s, the pharmaceutical industry adopted commercial freeze-drying for heat-sensitive medications. Today, it is a critical tool across various industries. The mechanism of lyophilization involves removing water from a product after freezing it, bypassing the liquid stage. Step 1 is freezing, where the product is cooled to a very low temperature, turning water into solid ice. This protects the product's structure. Step 2 is primary drying or sublimation, where pressure is reduced, causing ice to change directly from solid to vapor. This removes 90 to 95% of the water, keeping the product cold and intact. Step 3, secondary drying or desorption, slightly increases the temperature to remove any remaining bound moisture, resulting in a very low final moisture content for product stability. The flow chart of lyophilization shows the process starting with suspending the drug in a buffer solution and freezing it. The initial freeze-drying step causes sublimation. This is followed by secondary drying and then sealing the final product. Lyophilization, or freeze-drying, is a versatile preservation method across various sectors. It ensures the long-term preservation of sensitive materials without compromising quality or activity. Applications span pharmaceutical, food, biotechnology, and research industries. In the pharmaceutical industry, lyophilization is vital because many drugs are unstable in liquid form. Applications include preserving various vaccines, antibiotics like penicillin and cephalosporin, protein-based drugs such as insulin and aspirin, and injectable medicines like ketamine for anesthesia and enoxaparin for blood thinning. Lyophilization offers significant benefits in drug stability. It enhances drug integrity over time and allows for room temperature storage for long durations. This results in an easier to transport, lightweight, and stable formulation. Lyophilization is also crucial for gene therapy, a cutting-edge treatment that introduces genetic material to fix or replace faulty genes. The process preserves and stabilizes the gene therapy vectors, ensuring their biological activity for optimal gene delivery and therapeutic effects. This diagram illustrates the lyophilization of antibody-targeted plasmid DNA nanomedicine, showing the creation of Trojan horse liposomes and the use of hydroxypropyl gamma-cyclodextrin as a novel lyoprotectant, resulting in a lyophilized cake. The benefits of lyophilization include maintaining drug potency, making reconstitution easy before injection, reducing the need for refrigeration, and preserving biological activity. It allows for long-term storage, easy transport without damage, and increases the shelf life of medicines or drugs. In the food industry, lyophilization is beneficial for enhancing flavors, increasing shelf life, and preserving taste, color, nutrients, structure, and odor. It enables the production of instant coffee and tea, and preserves snacks and freeze-dried fruits with original quality and longer shelf life. Additional benefits for food include retaining flavor and nutrients, being lightweight and easy to store, having a long shelf life, and rehydrating quickly with water. In biotechnology and scientific research, lyophilization is important for the long-term preservation of biological materials, supporting numerous tests and studies. Lyophilization is effectively used to preserve microorganisms like bacteria and fungi for extended periods. This preservation method is essential for scientists, enabling them to maintain diverse cultures for research, quality control, and production purposes. The process detail for microorganisms involves freezing a bacterium, followed by the evaporation of ice. This yields a pure, dry, or lyophilized bacterium. When water is later added, the dry product is restored to its original condition. Enzymes and proteins are critical macromolecules in medicine, biotechnology, and food processing. Lyophilization preserves their activity and stability, enabling storage, shipping, and usage in various applications across these industries. One major benefit of freeze-drying is a long shelf life and improved stability. By removing water, Lyophilization minimizes the deterioration of sensitive chemicals, ensuring the material's integrity over time. Lyophilization is highly valuable in the pharmaceutical and biotechnology sectors for preserving the biological activity of delicate molecules like proteins, enzymes, and vaccines. This gentle technique reduces denaturation and activity loss, leading to more effective products. Lyophilized items are designed for improved reconstitution. They can be quickly restored to their original form by adding a suitable solvent. Furthermore, the reduced weight and volume of lyophilized products lower transportation and storage costs, making the process more economical. Despite its advantages, lyophilization has limitations, including high costs for equipment, energy, and maintenance. It is also a time-consuming process, and its complex operation requires precise control of temperature, pressure, and vacuum conditions. Other limitations include the high initial capital investment and ongoing maintenance challenges for specialized equipment. Additionally, the process is not suitable for all materials and has an environmental impact due to high energy use. Thank you for watching this video on the applications of lyophilization.